Imagine this. You're standing on the surface of a distant planet, looking up at a swirling luminous vortex in the sky. A strange force tugs at the fabric of space itself, creating a shimmering tunnel, an opening that seems to defy every law of physics we understand. What if you could step through it? What if in a matter of moments you emerged on the other side of the universe, billions of light years away? Sounds like pure science fiction, doesn't it? But what if I told you that NASA and leading astrophysicists may have found actual evidence that such a phenomenon could exist? For centuries, humanity has dreamed of interstellar travel, of reaching beyond our solar system and exploring the vast cosmic frontier. But the reality is daunting. Even with the fastest spacecraft ever built, it would take thousands of years just to reach the nearest star. The vast distances between galaxies make space exploration seem nearly impossible within a human lifetime. But what if there was a way to bypass those limitations? A cosmic shortcut hidden within the very fabric of the universe? That's where wormholes come in. First proposed by Albert Einstein and physicist Nathan Rosen in 1935, wormholes, also called Einstein-Rosen bridges, are theoretical passages that connect two distant points in spacetime. If they exist, they could allow us to travel between star systems, galaxies, or even different universes in an instant. But for decades they remained purely theoretical, just mathematical equations on paper. No one had ever found direct evidence of a naturally occurring wormhole, until now. In recent years, NASA and other space agencies have detected puzzling anomalies, mysterious gravitational distortions, unusual bursts of energy, and unexplained shifts in spacetime itself. But the most shocking discovery came when astronomers turned their attention to Sagittarius A, the supermassive black hole at the heart of our Milky Way galaxy. Strange anomalies. Near a black hole, black holes are the ultimate cosmic monsters, regions of space so dense, so powerful, that not even light can escape their grasp. But when scientists analyzed data from the Event Horizon Telescope, EHT, something didn't add up. Normally, light bends predictably around black holes due to their immense gravity, a phenomenon known as gravitational lensing. But near Sagittarius, astronomers noticed something unusual. There were moments where light seemed to disappear and reappear unpredictably, as if it were being pulled into an unseen structure within the black hole's gravity well. At the same time, NASA's Fermi Gamma-ray Space Telescope picked up bizarre gamma-ray bursts, intense flashes of high-energy radiation that shouldn't be there. These bursts weren't behaving like typical black hole emissions, and they seemed to be coming from nowhere. This raised an unsettling question. Could these signals be coming from a wormhole? It might sound far-fetched, but leading astrophysicists argue that if a stable wormhole did exist near a black hole, it could explain these anomalies. Unlike black holes, which trap anything that falls in, a traversable wormhole would allow matter, and even spacecraft, to pass through intact. How could we prove it's a wormhole? At this point, you might be wondering, how do we know it's not just a black hole behaving strangely? That's the biggest challenge. Proving the existence of a wormhole is incredibly difficult. However, researchers at the University of Buffalo have proposed a groundbreaking experiment using gravitational waves. Gravitational waves are ripples in space-time created by cataclysmic cosmic events like black hole mergers. If two regions of space were linked by a wormhole, they would produce a unique gravitational signature, one that doesn't match anything we've detected before. This means we might already have the tools to detect a wormhole. We just didn't know what to look for. And with next-generation telescopes like the James Webb Space Telescope, JWST, and upcoming gravitational wave observatories, we're closer than ever to proving whether these cosmic shortcuts exist. Could this change the future of space travel? Let's think about what this could mean for the future of space exploration. If wormholes are real, and if they can be stabilized, we could be looking at the greatest breakthrough in human history. No more waiting centuries to reach another star. No more worrying about the limitations of light-speed travel. The universe would shrink in ways we never imagined. But here's the big question. What if someone or something has already used them? Because if wormholes exist in nature, and they allow for instant travel across vast distances, could advanced civilizations already be harnessing them? Could UFO sightings, strange interstellar objects like Oumuamua, or unexplained fast radio bursts, FRBs, be linked to extraterrestrial travel through wormholes? These are the kinds of questions that are pushing the boundaries of modern astrophysics. And while we still don't have all the answers, one thing is becoming increasingly clear. We may be on the verge of the greatest cosmic discovery of all time. But before we dive deeper into the possibilities of interstellar travel, alien civilizations, and the role of wormholes in the multiverse, we need to take a step back and ask, what exactly are wormholes? How do they work? And why have they remained so elusive? To answer those questions, we must go back to the beginning, back to Einstein's mind-bending theories and the incredible science behind space-time itself. The science behind wormholes. Are they real? To truly grasp the significance of NASA's discovery, we first need to understand the science behind wormholes. Are they real, or are they just another theoretical construct, like time travel or parallel universes? Let's break it down. The Einstein-Rosen bridge, a cosmic shortcut. The idea of a wormhole dates back to Albert Einstein and Nathan Rosen, who in 1935 developed a concept now known as the Einstein-Rosen bridge. Their equations showed that space-time, the very fabric of the universe, could in theory fold upon itself, creating a tunnel between two distant points. Think of space-time as a sheet of paper. If you draw two dots on opposite ends and fold, the paper, the dots touch, creating a shortcut between them. That's the basic idea of a wormhole. If they exist, they could allow instantaneous travel between vast cosmic distances. But here's the problem. We've never actually seen one. So why do scientists still believe in them? The answer lies in general relativity, Einstein's groundbreaking theory that describes how gravity works. His equations not only allow for the existence of wormholes, but they also suggest that black holes, those terrifying cosmic vacuums, could be gateways to them. And that's exactly what NASA's recent observations seem to hint at. Why haven't we found a wormhole yet? If wormholes could revolutionize space travel, why haven't we already found one? The answer comes down to stability. Even if a naturally occurring wormhole exists, it's likely to be highly unstable. The moment matter, like a spaceship, enters, the tunnel would collapse faster than the blink of an eye. This is where a key ingredient comes into play: exotic matter. Exotic matter isn't like ordinary matter. It has negative energy and behaves in ways that defy physics as we know it. Theoretically, if we could find or create exotic matter, we might be able to stabilize a wormhole, keeping it open long enough for travel. Some physicists argue that the Casimir effect, a phenomenon where quantum energy creates a small repulsive force, could provide a clue to how exotic matter might work. If that's true, future advances in quantum physics could bring us closer to engineering our own wormholes. Are black holes wormholes in disguise? Now let's return to NASA's discovery. If some black holes, like Sagittarius A, are behaving strangely, could it mean they're actually wormholes in disguise? One of the biggest clues comes from the mysterious gamma-ray bursts detected near black holes. Normally, when something falls into a black hole, it's lost forever. But what if, instead of disappearing, some of that energy was actually being transmitted elsewhere? A team of scientists at the University of California, Santa Barbara, recently ran simulations to test this theory. Their results were stunning. If a black hole was secretly a wormhole, it wouldn't just consume matter, it would eject it on the other side. And here's the kicker. Some unexplained high-energy cosmic rays reaching Earth don't seem to come from any known source. Could they be particles that traveled through a wormhole? The Fermi Paradox and alien civilizations. Now let's take this discussion to a whole new level. If wormholes exist, and if they can be used for travel, wouldn't an advanced civilization have already discovered them? This brings us to the Fermi Paradox, the question of why in a universe with billions of habitable planets, we haven't encountered extraterrestrial life. One possible answer: they're using wormholes. Think about it. If an advanced species discovered how to stabilize wormholes, they wouldn't need to send slow-moving spacecraft. They could simply jump from one point in the universe to another instantly. This would mean that their travel wouldn't leave the kind of traces we expect, like radio waves or massive spacecraft moving through our solar system. Even more unsettling, what if they're already using wormholes to observe us without us knowing? Could some of the unexplained UFO sightings, or even the US government's recent declassified UAP, unidentified aerial phenomena reports, be linked to wormhole-based travel? If that's the case, it would mean we're not alone, and that we're far behind in understanding how the universe really works. The multiverse theory. Do wormholes lead to parallel realities? If we take things a step further, wormholes might not just connect distant parts of our own universe. Some physicists believe they could link entirely different universes. This brings us to the multiverse theory, the idea that our universe is just one of countless others. Some versions of this theory suggest that wormholes might be the key to traveling between these parallel worlds. The implications of this are staggering. If wormholes can connect alternate realities, it raises profound questions about existence itself. Are there other versions of us living different lives just a wormhole away? Could NASA's discovery be the first step in proving that our universe is just one in an infinite cosmic web? The next steps. What comes next? So where do we go from here? NASA, the European Space Agency, and private space programs like SpaceX are all working on new space telescopes and deep space missions that could detect gravitational anomalies linked to wormholes. The James Webb Space Telescope, JWST, is already looking deeper into space than ever before, and upcoming gravitational wave detectors like LISA, Laser Interferometer Space Antenna, might soon provide the first solid evidence that these cosmic sea shortcuts exist. But here's the real question. If we find a wormhole, do we dare enter it? The idea of stepping into an unknown cosmic tunnel is both thrilling and terrifying. If we send a probe through and it never returns, does that mean the wormhole was unstable? Or does it mean it reached somewhere beyond our comprehension? In the next section, we'll dive into the potential dangers of wormhole travel, the mind-bending paradoxes it could create, and whether the future of humanity depends on unlocking these cosmic gateways. The dangers, paradoxes, and future of wormhole travel. We've explored the mind-bending possibility that wormholes might exist, that they could be connected to black holes, and even that advanced extraterrestrial civilizations might already be using them. But what happens if we actually step through one? Is wormhole travel even possible? Or would it be a one-way ticket to oblivion? The dangers of entering a wormhole. Even if a wormhole could be stabilized, traveling through it would come with massive risks. Unlike the smooth, glowing portals we see in sci-fi movies, a real wormhole might be a chaotic, high-energy tunnel with gravitational forces beyond anything we've ever encountered. Here are some of the biggest dangers. 1. Spaghettification. Would we be stretched to death? Wormholes, like black holes, create immense gravitational forces. If the gravity at the entrance differs too much from the gravity at the exit, anything passing through, including a spacecraft or astronaut, could be violently stretched apart in a process known as spaghettification. Essentially, your head and feet would experience different gravitational pulls, stretching you into a thin, unrecognizable strand of matter before you even make it to the other side. Time dilation. Could we return to a different era, Einstein's? Theories suggest that time slows down near extreme gravitational fields. If we entered a wormhole and somehow survived the journey, time might have moved faster in the outside universe. Imagine stepping into a wormhole, thinking only minutes have passed, only to emerge thousands of years into the future. This isn't just science fiction, it's the real physics of relativity. Now consider this chilling possibility. What if someone entered a wormhole in an attempt to travel across the galaxy, only to return and find that Earth no longer exists? The sun might have burned out, civilizations could have risen and fallen, and everything familiar might be lost. Cosmic radiation, a deadly barrier. Wormholes, if they exist, are likely surrounded by extreme radiation. As high-energy particles interact with space-time distortions, they could create massive bursts of gamma radiation. potentially lethal to any organic life trying to pass through. Unless we find a way to shield ourselves from this radiation, even robotic probes might not survive long enough to send back data. Wormhole collapse, a death trap. Even if we found a stable wormhole, that stability might not last forever. A sudden shift in gravitational forces, a burst of exotic matter wearing off, or an unknown cosmic event could cause the tunnel to collapse mid-travel. If that happens, whatever is inside the wormhole could be trapped in an endless void, crushed by space-time itself, or simply erased from existence. The grandfather paradox. Could wormholes allow time travel? Now let's get even weirder. Some physicists believe that wormholes aren't just cosmic shortcuts across space, but across time as well. If that's true, stepping into a wormhole could lead to paradoxes that break reality itself. One of the most famous paradoxes is the grandfather paradox. Imagine you travel through a wormhole, arrive in the past and accidentally prevent your own grandfather from meeting your grandmother. This would mean you were never born, which means you never traveled through the wormhole, which means your grandfather actually did meet your grandmother, which means you were born after all. But then you did travel back in time, and the paradox goes on forever. Could wormholes allow us to rewrite history? If so, would the universe create self-correcting mechanisms to prevent such paradoxes? Some physicists believe that any action in the past would simply create an alternate timeline, meaning time travel wouldn't erase the future. It would just split reality into multiple branches. So if that's true, could wormholes be the key to unlocking the multiverse? Are we on the verge of a breakthrough? NASA and other space agencies are actively searching for signs of wormholes. The James Webb Space Telescope, JWST, is scanning deep space for anomalies, and upcoming missions, like the Laser Interferometer Space Antenna, LISA, will study gravitational waves, looking for signals that could indicate the presence of a wormhole. Meanwhile, theoretical physicists are working on ways to detect exotic matter, the key ingredient that could stabilize a wormhole. If we can find evidence of exotic matter in the universe, it might be the final clue that wormholes aren't just theoretical, they're real. What if we open a wormhole? The ethical dilemma. If scientists succeed in opening a stable wormhole, it would be the greatest discovery in human history. But it would also raise profound ethical and philosophical questions. Would governments classify this technology to prevent it from being misused? Could wormholes be weaponized, used to launch attacks across the planet in an instant? What if only the wealthiest nations had access, creating an even greater divide between the rich and poor? And perhaps most unsettling, would we attract the attention of civilizations far more advanced than us? If wormholes exist, and if aliens are already using them, would they see our first attempt to open one as a threat? Would they welcome us, or would they stop us before we could even try? The final question, should we step through? So here's the final mind-blowing question. If tomorrow NASA announced they had discovered a stable, traversable wormhole, one that could take us to a distant galaxy or even another universe, would we dare enter it? Would humanity take the risk, knowing that what lies on the other side could be wonderful or terrifying? Would we send a probe first, or would some brave astronaut take the ultimate leap into the unknown? Or would we realize that maybe, just maybe, some doors aren't meant to be opened? Let us know what you think in the comments. Would you step into a wormhole if given the chance, or do you think the risks are too great? Let's discuss the greatest cosmic mystery of all time together. Make sure to like, share, and subscribe for more mind-blowing space discoveries.